lesson today, atmosphere lesson one, it's going to deal with the season of the Earth. You can kind of see where we're heading for the next about 10 days or so. We're going to talk about high and low pressure systems, wind, how it forms, clouds, how they form. We're going to talk about weather, fronts, cold fronts, warm fronts, occluded fronts, stationary fronts, thunderstorms, how we predict some thunderstorms, and tornadoes themselves. But today we're focusing on the seasons on the Earth. And in class we talked about what makes seasons happen on the Earth, and we got a lot of different answers. We got to talk about people talking about the distance from the sun. We got people talking about the tilt of the Earth. We got people talking about climate and weather. Well, what we came up with was that it really is the reason what causes our seasons is the tilt of our Earth. Our Earth is tilted at 23.5 degrees. That tilt, as we revolve around the sun, leans the northern hemisphere closer or farther away from the direct sunlight, and that's what gives us our seasons. Now, if you looked at these two maps here, we talked about what are the differences. The kid said, well, right here it's June and here it's December, and the temperatures are different. You can see in New York it's 67 degrees in June, but in December it's 34 degrees. And we came up with, it's a different season. Now, with some of these animations that we're going to see, like this one right here, it kind of takes us through looking at our seasons. And, if we start to looking at December, winter, if you look at the Earth in December, the tilt is at 23 degrees right here. And you can look at the southern hemisphere right here, this bottom half, it's getting most of the sunlight, and we're only getting a little bit of that sunlight. That's why our temperatures are a little bit colder. It's because we're getting less of those direct rays. But if you look over in summer, you can still see the tilt as the Earth moves around. It stays the same. And when we get to summer, we look at it and we say, wow, now the northern hemisphere is getting all of this sunlight, which means we're getting more energy from the sun, which means our temperature goes up. That's why we have our warmer weather in our summertime. And in the southern hemisphere, it gets less, and they get less energy from the sun, so it's cooler. So truly, in our summertime is their wintertime, and the other way around. Their wintertime or their summertime is our wintertime. Now, in fall and spring, we get the same amount of sunlight and the same amount of night over the equator and in the northern hemisphere and the southern hemisphere. So spring and fall, temperatures stay relatively close to the same amount. Now, I want to point out a misconception here. This picture does a really good job pointing out the misconception. It looks like our trip around the sun is an oval, but the trip around the sun isn't an oval. It's circular. They just have trouble drawing it on a picture, a two-dimensional picture like this, to show that it's circular. So I just want to point that out, that our trip around the sun, our planet is the same distance away from the sun throughout the trip, but it's hard to draw. Now, in this other animation, it just talks about sunlight. In the wintertime, if you look at Fairbanks, Alaska, 4 hours of daylight, 20 hours of nighttime. Lima, Peru, right on the equator, 12 hours and 12 hours. New York, during the wintertime, only gets 9 hours, 8 hours of sunlight. The rest of it's dark. Now, in the summertime, it flips around. Fairbanks, 22 hours of light. That's way up here, but they get 22 hours of the 24 hours of light. New York, 15 hours. That's kind of like us. Lima, Peru, about 11 or 12 hours during the summertime. And in fall, we have equinoxes where we have 12, 12, 12, 12, and 12. And in spring, we have the spring equinox, 12, 12, 12, and 12. The thing I want to point out, though, is spring starts in March, and winter, December 21st. We said spring already, March 20th, 21st. Summer, June 21st. And in fall, September 20th, September 21st, right around in that area. There's the equinoxes in the fall and in the spring, and something called a solstice in the summer and in the winter. Summer, we get more sunlight. Winter, we get less sunlight. Spring and fall, we get the same amount of sunlight. So to answer our question of why do we have seasons, it can be kind of explained right here on this sheet. The way that the Earth moves, we move in two ways. We rotate, we spin. That gives us our day and night cycle. It takes about 24 hours to make one rotation. We know that because day and night, the sun's up, it's day, and the sun's not in the sky, it's night. takes about 24 hours. The second way that we move is when we move around the sun. We revolve around the sun. It takes about 365 days. It's that tilt that causes the seasons on our planet. This tilt plays that major role in causing the seasons. The tilt of 23.5 degrees tilts some of the Earth towards the sun at some time of the year, tilts it not so much towards the sun. When it's not towards the sun, we don't get as much energy, we don't get as much heat, we get cooler temperatures. So that tilting towards the Earth, we get more sun, we get more energy, we get more heat. So big, ticket here that you have to remember is Earth's rotation, the spinning causes day and nights. Earth's revolution causes a year, and the sun's or the Earth's tilt gives us more direct rays from the sun. This image right here shows direct rays going over the northern hemisphere in summer. We get a lot of them, warms us up, but in the winter, where the tilt stays the same and we get less. So all in all, the tilt of the Earth causes us to have seasons. We tilt towards it, we get more. We are tilting, so we're not getting as many direct rays. We get cooler, that's our winter. More, it's our summer. Equally, it's our fall and our spring. So all in all, that's kind of what we talked about. Have a good night.